I'll tell you right now, I've got more information than I have time, so let's move right into it. For HY8, our biggest update is that right now there isn't a current update. We're working on the next version. The next version is focused primarily on bug fixes, no new features. So far, we've got 29 bugs fixed. The bug fix that we are spending the most time on is there's this issue with the embedded circular culverts, and specifically in the 50% embedded circular case. So right now, we recommend not running those type of situations through HY8. The inlet coefficients are wrong. If you do need to do that, you can put it in as a user-defined shape and continue to run that case using interpolation coefficients. Not quite as precise as polynomial coefficients, but they'll get you started and with a good test case situation. We also wanted to mention that we are doing testing with HY8. Every time we build HY8, we have 61 model files that we run through the HY8 engine to test the computations to make sure that they are not changing in ways we do not expect. And on top of that, we have additional internal computation tests that are completed with every build as well. We have GUI tests that are performed regularly, which I can normally say, just not in front of a group of people. But still bugs slip through our testing nets. It's also difficult to find new models to run through our testing situation that just doesn't add unnecessary computation time, as well as time maintaining it, because then we'll go through and we'll say, oh, well, we've got an updated coefficient that we want to start using now. We'll plug that in, and then, oh, now we have 10 tests that we need to go through and modify 100 values on to update them to what they should be. So it just takes time. But to help with this, we've added a website. And on this website, you're allowed to download the existing testing data that we are currently using, and you can also submit new test cases. So bring up this website. Hopefully it won't take too long. Nope, it's not going to let me. You go to that website. On the left side, it'll allow you to download the information, give you some metadata for it. On the right side, submit a new test case. For Hydraulic Toolbox, you might notice a common theme here. There's no big changes in the main interface. The Hydraulic Toolbox on the left is the old one. The one on the right is our new one. They're the same. But if you bring up the bridge scour calculator, which is used to compute long-term degradation, your main channel contraction, pier scour, and abutment scour at a bridge location, previously these were all computed individually. And then you had to take that information and figure out what it meant. Now, we've put this together in a project, and we pull together the scour depths and add them together for you, which sounds really easy, but it's tougher than it sounds. We can now also import from HEC RAS. We can plot the cross sections, but that is optional. You don't have to enter in all the geometry if you don't want to. And we also include a summary table with the scour results there. So now let's switch over to Hydraulic Toolbox, and we'll show you what we mean here. So this is the new scour tool. Everything is turned off by default. If you want to see different calculations, you click to enable it. So we're going to enable long-term, and the only option here is just to define what it is that you want. This dialog is what we had previously, so it just defines the parameters for specifically long-term degradation. We've added this spot where you can just specify a scour depth. You know that your scour depth in the long term is going to be 6 inches, so you just want to be able to enter that in directly. Then we go into the main channel contraction scour, and here we have an option to enter in a left bank station and a right bank station. If we do that, then we will have our overbank contraction scour options enabled. And again, this is that same kind of dialog from before, but this time it's for contraction scour. We turn on piers, and here we can specify a number of piers. We're just going to keep it at 1 for these purposes now. We can give it a name, so we can tell it from all the other ones, so we'll call this one Bob. You can, same as before, define our parameters that will determine your scour depth at that pier. And then we have the scour reference point. The point is here, that your channel and the thalweg of that channel can migrate across your piers. And so if you are determining your scour depth at the location of the stream bed at that pier, you're going to be not designing as adequately. So you can assume a thalweg, so we'll go down to the thalweg elevation and scour down from the thalweg. But maybe you're clear up on the overbank and you know that channel's not going to move over there. In that case, you can select a local scour depth, and it will just start at where the pier meets the stream bed. And then we have a left abutment, and pretty similar. We have the ability to define our options and choose our reference point. One thing I forgot to mention on the piers, it's best to go through and do just one pier first, define all your parameters, and then duplicate it. That way, you have all your parameters duplicated. You don't have to go through, run through that dialog several times. You just have them all set for you. So that is, in a nutshell, the project summary of the hydraulic toolbox. To show you what we can do with the plotting, I'm going to enable the scour plot options this time, and we're going to import geometry from a HEC-RAS file. So this is just going to be coming into here, pull in our PRJ file. We're going to select our approach cross-section. I can click here to view it, which will bring it up in the cross-section as a channel in Hydraulic Toolbox. But I can plot it and view it and see what information is coming in. This is a viewing, not an editing at this point. And then we select the cross-section for the bridge. And again, we can view it. And then you select the bridge that you want to use. At that point, it brings in the abutments that are attached to that bridge, as well as the piers. I look it over and check on things. Looks good. I click OK. Now I can come here to plot it and take a look at what that bridge looks like. In this situation, everything is using that thalweg elevation, but because I did not bring over any parameters to be able to determine any scour depths, all our scour depths are 0, so everything's just lining up with our thalweg. If I came back here and I changed this guy to be, well, we'll change pier 2, and we'll change it to be a local, and I come back here, that scour depth disappears because it's not starting at the location of the thalweg. But again, this isn't as interesting because we aren't pulling in any information at this point. Going to continue with our presentation slides a little bit, and we've been doing a little work with SRH and SMS. So we've added an option to be able to export information from SMS and bring it into Hydraulic Toolbox. This makes it easier to bring in some of the more difficult to measure variables into Hydraulic Toolbox. It allows you to combine the precision of a 2D model and be able to bring that into the specialized scour computations of Hydraulic Toolbox. What you're going to need is a mesh with a water surface elevation, a water depth, and a water velocity, with those being in data sets. And the way we do this is we have archetypes, a specialized coverage in SMS. It's called the bridge scour coverage, and we have several archetypes in it. For the user, we're going to create an approach arc, and this is going to be just upstream of where the flow vectors start to converge, where it's outside the influence of the bridge. And then we're going to have one where the scour, which is where the bridge crosses the river, where we're trying to find what the scour options are going to be. A center line that follows the channel from the approach to the scour arcs. And we're going to have bank arcs that they only need to intersect the approach and the scour arcs. And then you have the abutment toe to demonstrate where your abutment toe is, and this is only important to intersect the scour arc. And then we're going to have pier location, which will also specify the length of those piers. So let's take a look at how we would do this. So I'm going to pull up the Gila River model that we are using. I'm going to zoom into our area of interest. And first thing I'm going to do is create a new coverage of bridge scour type. And this is going to bring up our bridge scour coverage properties. I come into here and I'm going to define a gradation. This is a completely made up gradation. You should be able to tell where those values are coming from. In other words, don't use this if you're doing modeling. And then we're going to select our mesh. This is coming from our data there on the left, just this mesh data set. And you can select which mesh if you have multiple meshes. And I'm going to select the data sets for water surface elevation, data set for water depth, and then one for velocity. These other options I'm going to come back to in a minute. So I'm going to close this dialog, and now I'm going to create our arcs. So the first one is our approach, and I'm going to guesstimate right about there for our approach arc. Our roadway is going to come across here. And SMS has a predetermined path that it takes through these arcs. So the very first one it created was an approach arc. The second one's going to be the scour arc. You can go through and change them. You don't have to follow this option, but it does make it so you don't have to click on a bunch of arcs and change them constantly. The next one is going to be the center line. So I'm following our depth data set, kind of following the deepest parts of the channel, but I am on a touchpad, so we're not talking great accuracy here. And now we're going to create the main channel bank arcs. You can define these either way you want to. For example, you can create just one continuous arc that follows through the model and says, there's my bank. It intersects the approach and it intersects at the scour. Alternatively, you could just put in two small, short little bank arcs, and that works too. I'm going to have to zoom in a little bit here because we're going to put in abutment toe arcs. And I might just accidentally click the right button. Here we go. And so we're going to say our abutment toe is about here and about here. So then SMS is going to be able to determine along this arc where the abutment toe is located. And I'm going to define our pier right there. Now I need to check these last two arcs, make sure that they came up correctly. See, it came up as bank arc. We want to switch that to abutment toe. And this one is set as abutment toe. And then we're going to come in here to our pier, change it to a pier, and then we define a width. I'm just going to give it a 5. And now we've defined everything we need to define for this bridge scour operation. So I'm going to come back to that dialog that I showed you earlier. Bridge scour properties. And this will define everything we need to export to Hydraulic Toolbox at this point. We have this option here, which is called Streamlines. I'm going to talk about that a little bit more in just the next slide. This is an experimental feature. We're just using it with federal highways right now. And again, I'll give a little more information on that. So we're going to use bank width ratio for our contraction scour extraction approach. And then we have this other option, which is the NCHRP abutment scour condition. And I'll talk about this in a little more depth in a minute. We're going to choose a main channel in this situation. Choose a file you want this to export to. And then we click View Values. This is so that we can double check and see what's going on with our model. So there's a couple of errors that it picked up in this situation. It couldn't pick up any flow going across our abutment toe, so it's giving me an error there. And I'm going through this kind of quick, so I'm not necessarily putting it all together correctly. And this just gives you the hydraulic information of the approach section, the contracted section, or the scour section, as I've been calling it, the local approach section. When SMS does this, it's going to generate a few arcs, and one of them is approach section and streamlines, and it gives you information for all of these parts that it's extracting information out of this 2D model so we can put it into Hydraulic Toolbox and leave less information for you guys to go out and figure out where it is in the model and bring it over. So you check over that, and once it looks good, you can export it. I'm going to take a quick pit stop over down here at the advanced options. So this soil gradation that we entered in earlier, that is used to determine a critical velocity. We can come into here and we can say, you know, that's really more than we should have. It's really about 3 feet per second when our sediment starts to move. I'm going to override that computation and just hard code and say, choose a 3 for me. And then the rest of this, Hydraulic Toolbox asks for these variables several different places. And rather than have to go through and change them consistently each time, you can come in here and change them in one spot, and it'll update all of those variables for you when you bring it up. So if you're working with just slightly changed variables, you can make that change. All those arcs that I told you about that are generated by SMS, you can delete those by clicking this button. But this time we're going to export this data file. And again, it pops up this warning, so I just don't blindly get in there and wonder why it doesn't have anything on that abutment toe. Now we can bring up Hydraulic Toolbox. Come back here where I've saved out that file. Bring this up. And while I don't have the bridge geometry and the bridge deck, the abutment geometry entered in, we do have our pier in here, and we actually have computations taking place on this pier. It's giving us the scour depth of this pier at this location. If I had the abutments, it would also place in our abutment scour holes and our long-term degradation. This doesn't put in all the information we need for all of the calculators to perform their scour analysis, but it gives us most of them. In this situation, I need to come in here and give a K1, and then we would have that contraction scour. Another thing I should point out, when we enable the scour plot options, we do have a few more options in our Hydraulic Toolbox. First off, we have our bridge cross-section geometry, which is our cross-section that goes underneath the bridge. And we have the bridge deck geometry. Again, we don't have that in this particular model. And an approach cross-section. Both of these cross-sections were brought over by SMS, just pulled off of the terrain. And then we've got a geometry and a center line for our piers, so it knows where to place them and how to plot them vertically. And if I would have had our abutments, it would have brought those over just fine too, and populated the data for those scour computations. Finally, we can come in here to our bridge scour summary table, and normally has a bit more information. It gives us our contraction scour, pier scour, lines them all up here so you can go through and take a look at your elevations and see all of this in a table. Or if you want to see them in a cross-section, you can plot it in your cross-section and see it visually. Okay, real quick, I wanted to mention that Streamline issue. So this is the experimental feature that we are looking into. The bank width ratio follows what we do in HEC 18. Streamlines is using a new idea where we're following streamlines through this cross-section. But again, it's all experimental. We're looking into it. If you are interested in discussing this idea further, contact Scott Hogan, and he's be more than happy to work with you on that. And that pretty well concludes what I have time for. The bottom line is these updates are less about adding new features, but improving the features that we already have. Hydraulic Toolbox is now released. You can now download it. Next HY8 version, we don't have a release version for that, but we are working on bugs, and we'll have one coming out shortly. Do we have any questions? For exporting from SRH 2D model, I am not aware of a tutorial yet. We do have documentation that is ready for once SMS is released that will provide a walkthrough and definitions of all the arcs and some guidance on where you place them. but we don't have a tutorial yet.
Other questions about it?
Okay, thank you.